Okay, so this is week 3 homework, and I'm going to be doing week 3 homework 1, questions 9, 10, 11, and 25, and week 3 homework 2, questions number 3. So the first one is find the domain of the function defined below, or as follows, and that is f of x equals the square root of x squared minus 3x minus 4. So it is a square root function, which means we need everything underneath the square root to be greater than or equal to 0. So I need x squared minus 3x minus 4 to be greater than or equal to 0. It's a quadratic, so I'm going to factor x minus 4, x plus 1. I'm going to choose x equals 4 and x equals -1. Those numbers I'm going to put on my number line, -1 and 4. I'm going to choose numbers in those intervals to decide if it's positive or negative in those intervals. So I'm going to choose -2. If I plug -2 into that factor on the left, I would have a -2 minus 4 and a -2 plus 1. That's going to give me a negative times a negative, which is positive. If I choose a number between the interval of -1 and 4, if 0 is in the interval, I always choose 0. So I'm going to have a -4 times a positive 1, which gives me something that's negative. If I choose something larger than 4, then let's say 5, I'm going to have a positive times a positive, which is positive. Okay, it is greater than or equal to, so I can include -1 and 4, so or equal to. And it's greater than or equal to, so I want things that are positive because positive things are greater than 0. So I want this interval and this interval. So the domain is going to be -infinity to -1, union 4 to infinity. All right, so that was number 9. Let's take a look at -10 or number 10. So this is similar, except for it's underneath, it's in the denominator. So we also can't have things that are equal to 0 in the denominator. So instead of saying everything's greater than or equal to underneath the square root, we're just going to say greater than because it's in the denominator. So we don't want equal to 0. So I have 7x squared plus 6x minus 1 is greater than 0. All right, I am going to factor. I have a 7x and an x. They have to multiply to be 1. I want the one that's multiplying by the 7x to be positive because I have the middle term to be 7x. Okay, so I have x equals a 1/7 and an x equals -1. So I'm going to put those two numbers on my number line, so -1 and 1/7. I'm going to choose something less than -2. All right, to find again in the interval if it's negative or positive. If I choose -2, I'm going to have a 7 times -2 minus 1, and -2 plus 1. That's going to give me something negative, and that's also going to give me something negative. Sorry, I'm laughing at my dog. 1 second. Other stuff. All right. So that gives me something positive. Between -1 and 1/7, I get 0. So I have a -1 and times a positive 1, which gives me something negative. And let's choose something bigger than 1/7. Let's just say 2. And that is going to give me something positive times something positive. All right, this is not or equal to 0. So I'm going to have open circles because I'm not going to include those points. And I want things that are positive because those are greater than 0. So my domain is going to be negative infinity to negative 1, union 1/7 to infinity. So that's my domain. All right, on to the next question. All right, it says write an equation that defines a rational function with a vertical asymptote of x equals 3 and a horizontal asymptote of y equals 2. So before we even look at what they have over here, let's talk about vertical asymptotes. So vertical asymptote is when I have something that is undefined in the denominator and it does not have the same factor in the numerator. All right, so what I want in the denominator is an x minus 3. Let's try that again. All right, now I want a horizontal asymptote of y equals 2. So remember when we are talking about horizontal asymptotes, if the degree of the numerator is less than the denominator, then I have a horizontal asymptote of y equals 0. If the degree of the numerator is greater than the denominator, then I do not have a horizontal asymptote. If the degrees are the same, then it is leading coefficient over leading coefficient. So since my leading coefficient in the denominator is 1, I need my leading coefficient in the numerator to be 2. All right, so I could just say 2x, or a 2x minus 5, or a 2x minus 10, whatever. So then now what we're going to do is we are going to look at our options. And the only option that could be a possibility is B, all right? Because the horizontal asymptote in this one would be y equals 3. The horizontal asymptote in this one would also be y equals 3. And the horizontal asymptote in this one would be y equals 1, and the vertical asymptote would be x equals 2. All right, so our answer is B. All right, last one is write a function as a composition of two functions. All right, and this is the one where we want to think about an inner function and outer function. Okay, so I see that I have an x squared plus 8x and an x squared plus 8x being raised to some power 2 times. So that is going to be my inner function. All right, so I'm going to have g of x equal to x squared plus 8x. All right, so now I want to write my outer function, which I'm going to let be f of x. All right, the first time it's being raised to the 1/3. The next time it's being raised to the 2/3 and being multiplied by -3. And then I also have this plus 5. All right, and then I want to check to make sure it works. So f compose with g. So if I plug g of x into my f, will I get this function y back? So x squared plus 8x. So if I plug x squared plus 8x into x to the 1/3, x squared plus 8x to the 1/3 minus 3 times x squared plus 8x, I'm out of room. Let's move this over. To the 2/3, whoops, plus 5. All right, so I get that back. Let's see if we have a correct choice here. It says if x squared plus, if f of x equals x squared plus 8x. Okay, so it looks like they are switching f and g. All right, so let's see. If f is equal to x to the 1/3 minus 3x plus 5, okay, they have that here. And g of x is equal to x squared plus 8x. All right, so it looks like our answer is B. Let's just check some of these. Okay, C is wrong because they have x cubed. A is wrong because they have the inner and outer function switched. If they had rewrote it as g of f of x, that would have been fine. And then D is just all kinds of wrong. All right, so that is it for this video. Have a good day.